met before, my name is Nama Blonder. I'm an architect and urban planner with Smart Density. Our webinar series picks topics that we find interesting, and we assume that you would find them interesting as well. And today we invited Element 5 to join us. I would like to introduce Patrick and Lee. Give me just one moment. Okay, so we are joined today by Element 5, and Patrick and Lee will be today's speakers. Patrick is the founder and director of business development at Element 5, and Lee Scott is the Canadian sales and business development manager at Element 5. Patrick and Lee, if you would like to introduce yourselves in a little bit of more lengthy than what I just had, but thank you very much for being here. I think it's a topic that I hear clients talk to me about all the time. We want to be innovative. We want to understand what are the alternatives to concrete and steel in today's development. And this, all yours. And thank you for joining me.
Great. Thank you very much, Nama, for organizing, and thank you everyone for joining us this morning. Lee, I guess at this point we'll share our presentation.
Yes, thank you, Nama. Just pull up our slide deck we have here to share with everyone today. Nama, are you able to see that, and Patrick?
Yes.
All right.
Great. Great.
Turn it over to you then, Patrick.
All right, thanks. So we are Element 5. We consider ourselves to be world leaders in the mass timber revolution, and I'll explain what that is in just a moment. The image that you see on screen here is our brand new manufacturing facility in St. Thomas, Ontario. We produced our first panels in December of last year, and we're now fully compliant to produce both CLT cross-laminated timber panels and glue-lam for mass timber projects. So next slide, please, Lee. To put what we're doing in our industry in context, I thought I would give you a quick overview as to what's happening in the mass timber revolution on a global basis. We're in the midst of a revolution in mass timber, and it started in Europe about 30 years ago and is now well upon the shores of North America. It's characterized by buildings that are being prefabricated in high-tech manufacturing facilities and are being shipped to site where they are being assembled rather than constructed in the traditional sense. And Element 5 is one of the leaders in this industry based here in Ontario. The building that you're looking at here is the Brock Commons student residence, which many of you may be familiar with already. It stands on a concrete podium, and on top of the podium stands the glue-lam columns that you see on the left-hand side. And then on top of the glue-lams sits these massive wooden panels that are called CLT, or cross-laminated timber panels. They're structural panels. They're used for floors, for walls, for roof structure, for elevator shaft. They are a environmentally friendly alternative to concrete. So mass timber buildings today are being built entirely out of these solid panels. And one of the interesting things about this particular building is also the use of these prefabricated panels on the outside of the building. So the panels that you see here are pre-manufactured in the plant. They come with a CLT interior layer, the insulation pre-installed, and ultimately the windows and the doors. And as the structure of the building goes up, the crane comes and picks up these panels and quickly fastens them to the outside of the building. This particular building, at 18 stories tall, was rendered completely weathertight in mass timber in a matter of 9.5 weeks. Next slide, please. So, as I indicated, the wave of the use of these materials landed on the shores of North America about 10 years ago and has worked its way all the way across the country and is now well into the United States. Just here in Ontario, this is a small selection of the buildings that are in various stages of design, development, or completion. So Ontario's taken up mass timber in this form of offsite manufacturing in a big way. Almost every major college and university in Ontario is building a mass timber building. Next slide. So why all the interest in mass timber? Well, it really depends on who you're speaking with. Firstly, owners and developers, the conversation is almost always about return on investment. And because we can manufacture buildings more cheaply in a high-tech manufacturing facility, it means a lower cost of construction. But at the same time, occupants are generally willing to pay a premium to be in these absolutely beautiful, environmentally friendly buildings. So for the owner developer, it's about lower cost, higher selling price, and therefore a higher return on investment. So it's the owner developers that are driving the push into this form of construction. When you're speaking with the environmentalists, the world is desperate for solutions to the carbon dioxide crisis and climate change, and building with wood offers a real solution to the problem. As world population grows from 7 billion to 9 billion people over the next 30, 35 years, we know we cannot continue to build the way we've been building for the last 100 years or so. When we're building with wood, what we're doing is we're leveraging our forest's natural ability to absorb carbon dioxide, produce the oxygen that we breathe, and store the remaining carbon in ever-increasing amounts of wood. And if we manage our forests effectively, as we do here in Ontario, or in Canada rather, and we use those materials to build things, in this case buildings, unlike the concrete and steel industries that are spewing carbon dioxide into the atmosphere, we found a way of systematically removing it from the atmosphere and storing it in the form of these beautiful buildings. And lastly, communities. I'm referring to the people that occupy these buildings. There's been a number of health studies that have been done, biophilic research that shows that there are health benefits associated with living and working and educating our children in environments where they're exposed to natural elements. And in the design of our buildings, we try to expose as much as the wood as code and acoustic code and fire code will allow. And so you're getting the wood exposed, and so we're creating these wonderful, healthy, natural environments for occupants. Next slide, please. This slide will give you an indication as to what some of these buildings look like on the inside. So the top row are residential buildings, the bottom row are commercial buildings. So I hope you'll agree they're quite lovely buildings to live and work in, and we can now produce them much more economically. Next slide, please. And with that, I'll turn it over to Lee.
Perfect. Thanks, Patrick, and then thanks, Nama, for organizing this, and thank you, everybody, for joining. So that was a pretty good overview of the mass timber industry by Patrick, and I just want to touch on a few more points and get into a little bit more depth on industry specifics. So we're going to talk about, what is mass timber. The two components, the main components, are CLT and glulam. So we'll explain those a little further. We're going to touch on more of the benefits of mass timber. Patrick, highlighted quite a few of them, but we'll just reiterate a few of those points. Some of the building applications where we see this product being used, and its advantageous, or its advantages in those particular building applications. And we want to talk about prefabrication, building off-site in a factory, and why that has advantages for cost savings, time savings, and overall performance of the building. And then we're going to just go through 10 of the keys for a successful mass timber project that we've established throughout our experience in the industry. So first of all, mass timber, there's a few different components that can make up the structure of the building. And one of the major ones is cross-laminated timber. So I'm sure you keep hearing CLT, CLT. So CLT, so what is it? It's basically, it's a large-scale prefabricated solid engineered wood panel, and it's used for the floors, the roof, and the wall applications of the building. It's very lightweight, it's strong, and it has excellent performance criteria. So, the characteristics such as fire, acoustics, and seismic, it performs very well in all these areas. One of the main things is it's very fast and easy to install, and there's almost zero waste on site. So as Patrick mentioned, you're not really constructing these panels on site, you're just assembling them. They're like giant Lego blocks that put this building together very fast. So the panel itself consists of several layers of kiln-dried dimensional lumber material. So basically, we're just taking regular lumber from Home Depot per se, same kind of stuff, 2x4s, 2x6s, and you're stacking that in alternating layers in order to achieve these massive rectangular panels. They're all bonded and then pressed in a massive press in the factory. And then those big master panels, we'll touch more on the panels that we make here and the sizes of them. Those get cut up into individual panels, and any sort of mechanical or electrical or plumbing penetrations in the panels are already cut in our factory. So we cut out all the penetrations to reduce the construction schedule on site and make it that much easier and faster for the MEP guys to start fitting out the building. So that's CLT. You can see here on the right-hand side, it comes in several different layers depending on the structural criteria of the building. We have a 3-ply, 5-ply, 7-ply, 9-ply. We do it in odd number of plies, so you get strength in the major axis and you get strength in the perpendicular minor axis. And that makes the panel itself very dimensionally stable because you have strength in both directions. So you can see here, this is a little bit more specific to element 5 CLT. There's a few different varying strength grades. There's a visually graded lumber that we can use, or there's a machine stress that's called an MSR rated lumber that we can use. And that gives some different strength criteria for engineers to have a bit more flexibility in their design and how far the panel can actually span. For element 5, we have one of the largest panels in North America. It is up almost 12 feet wide, so it's 3.5 meters wide and up to 16 meters long, so almost 53 feet long, which is pretty optimized for shipping to site. And so that's almost 600 square feet you're putting up in one crane pick potentially. So that shows you how fast these buildings can go up. And when it comes to construction and putting these prefabricated elements in place, it's how many crane picks can you do and how much area can you put up per crane pick that dictate the overall construction schedule. So you can see here at the bottom, we have a few different options for 3-plies and 5-plies and 7-plies. And then we have our big monster 9-ply, which you see up in the upper right corner. So that's a pretty hefty panel. So that's pretty much CLT. The other major component that helps with the building for the vertical structure and the supporting horizontal structure is glulam. So it's similar to CLT, but a little bit different, where you're only stacking the dimensional lumber and pressing it in the one direction. So you take a bunch of 2x6s or a variety of these dimensional lumbers and stack them. And we can do columns and beams up to about 5 feet deep and anywhere from 3 inches wide all the way to a foot wide. And then we can actually take those members and we can glue those bigger members together to make even larger members. So on some of these big projects, like you can see some really hefty, massive wood columns or beams, at the ground level where the forces are higher. So it's pretty amazing the stuff that we can put together in the factory. All of these products are made from local Ontario SPF lumber. So the glulam matches the CLT perfectly for aesthetics. And it all comes from sustainably harvested forests. So that brings me to some of the benefits of mass timber. So this mass timber checks a lot of boxes. There's a lot of reasons why this industry is absolutely exploding right now. The first one we touched upon, already is the speed of construction, how fast these prefabricated elements can go together. When the concrete foundations are being poured, or if there's an underground parking, while that construction is going on site, we can be building the building in our factory in parallel. So that's a time savings there as well. But basically, by reducing the amount of crane picks and time on site with different with labor, we're just reducing the overall construction schedule. So we can actually be 25 to 40% faster than a traditional concrete or steel building. And that results in people getting in the building faster. It results on a faster return on investment and overall savings for the whole building. I'm sure everybody's seen this picture on the right recently of the old growth forest being harvested in Vancouver Island. And some of these trees are thousands of years old. The nice thing about mass timber, aside from the carbon sequestration that Patrick talked about, is that we don't have to cut down these old growth forests anymore to get big, huge columns like I was talking about with the glulam. So in older timber buildings, if you needed a huge column, you had to cut down a tree just as big. With this new engineered technology and the adhesives we're using, we can use fast growth, sustainable forests and sustainable wood in order to make those larger members without cutting down these old growth forests. So it's a huge benefit, and we don't have to see these beautiful older trees get cut down anymore. We can do it sustainably. As far as safety and performance, there's less people on site, which means less chance for error, for people getting hurt on site. There are less trades, less people, higher safety rating. In the factory, you're doing the same thing over and over again. It's an industrialized process, and we have safety measures in place. on site, there's a little more variable and things that can go wrong. So the safety and performance, as well as the safety and performance of the product, it has very good characteristics for seismic and fire. Another great benefit is the reduced structural weight. Timber weighs less than concrete and steel. It's pretty simple math. So with less weight, we can make the foundation smaller. And so that reduces the amount of concrete, which reduces the amount of CO2 produced by that concrete. And we can also build on building sites that might not have been possible before because of the soil conditions. Since timber is a lot lighter, you don't need as much soil remediation in order to build these buildings. So it's exploring new opportunities to build a little bit lighter and a little bit cheaper and a little bit more environmentally friendly. As far as thermal performance, wood is a natural insulator, unlike concrete or steel, so you get a higher performance building. And we're going to talk about some of our prefabricated envelope panels a little bit later that really highlight the thermal properties of wood and a high performance envelope. So you're not having all this thermal bridging and energy loss. So it's a really energy efficient building. And Patrick, touched upon already the biophilic benefits of wood. It's nice to be in a wood building. There's studies that show people are just happier in a wood building. I know I work out of a mass timber building downtown Toronto, and it's just a nice place to be. And aesthetically, you have less finishes because you can leave the wood as the final finish. So lots of boxes that it checks, and we're happy to discuss more. Here is a picture of our brand new factory. So it's pretty cool that Element 5 just opened Ontario's first and only CLT manufacturing facility in Ontario. And it's 137,000 square feet. It's absolutely massive. You can see one of our panels about to go into our X press there. So that's a CLT panel about to go into our 3.5 meter wide press. But just having this manufacturing facility close to the GTA and in Southern Ontario makes logistics and the overall cost of a project a lot more palatable. And we're able to be very competitive with concrete and steel, having this factory, in close proximity to so many job sites. We strategically placed it close to the US border so that we can, feed areas like New York, Chicago, Boston, Philadelphia, as well as the GTA and Quebec and the Maritimes. So it's really awesome to have this huge facility in St. Thomas. We can do about 45,000 cubic meters of CLT a year out of this facility and about 5,000 cubic meters of glulam. So in comparison to that building, the Brock Commons building that Patrick showed you at the beginning of the presentation, the 18-story building, we can do about 15 or 16 of those buildings per year out of this factory, and maybe even more if we add an extra shift. So there's a short little video I just wanted to show you of the automation. This is one of the most automated factories in the world for CLT. Basically just a vacuum section picks up a 2x6 that you see there at the beginning of the automation line, and nobody touches the wood. And at the end of the line, it either spits out a column or beam from the glulam line or a CLT panel from our CLT line. So it's completely automated. Very few people are needed to run the equipment, and that optimizes costs, increases safety in the facility. And then everything is finger jointed. You can see our finger jointing machine there. And then everything is beautifully bundle wrapped and ushered to site using just-in-time delivery. That's our 5-axis CNC machine. So that cuts all the penetrations for mechanical, electrical, plumbing into the panels before they get to site. Basically, everything is done in the factory. A little overview there. If anybody has any interest of doing a tour, we'll be doing, once the COVID restrictions ease a little bit more, we'll be doing regular tours at the factory. So I just wanted to briefly touch on some of the applications. We do everything at Element 5, from single family houses all the way up into 18, 20-story condo buildings. There's several buildings that we have in our pipeline right now between 4, 6, 8, 12 stories in the GTA. So we're going to be starting to see more and more of these residential buildings pop up. And it's not hard to tell why when you look at a picture like this and see how beautiful these spaces can be. Office applications, so commercial and office space, COVID hit the industry a little bit hard there, where they weren't building too many offices because nobody was in them. But we're starting to see that come back. And, the companies like Google, Amazon, Microsoft, Facebook, they're only building mass timber buildings now for their people. Is really taking off in the industry, and that's because it checks all those boxes of sustainability, cost, and speed of construction. And it's just a great work environment. People are paying more to be in a mass timber building because it's just a nice place to be. The colleges and universities is also another big driving force. This is a rendering of the Lawson Center of Sustainability at University of Toronto that Element 5 is working on with Grand Construction and a few other project stakeholders, but it's a 280 student bed academic hall and student residence, University of Toronto, downtown. It's 4 stories, and it's utilizing some of our prefabricated elements that we're going to talk about here soon for the exterior wall. This is the Oakville Fire Hall. So we also see a big movement in fire halls, public schools, and public buildings as one of the industry segments where we see mass timber take off. You'll notice in this building, it's a little interesting that you see steel columns and brace frames, but then we actually used a prefabricated mass timber wall envelope, which you can see the inside there. They left that exposed wood, and it looks gorgeous, and it saves on drywall and painting and all of that stuff. So you have reduced material and you get the beautiful exposed wood. So just to talk a little bit more about prefabrication and the advantages of doing that off-site, I like to say it's always sunny in the factory. The lighting is perfect 24/7. You can work 24 hours a day if you need to. The tolerances that you're working towards are a lot better than the tolerances you would see on site. So you're getting a higher performance building out of the factory, and we can find efficiencies and processes to do this process over and over again. Whereas on site, you're kind of doing things one-off, and it's not as efficient. So there's tons of advantages to prefabrication, and we're just starting to scrape the surface, I feel. One of our products at Element 5 that we see is really catching on in the industry is our cross-laminated insulated panel. We call it our clips panel. And basically that's for the envelope of the building, just like we did on the Oakville Fire Hall that you saw there. And that panel can come to site with, the insulation, the weather membrane, strapping, cladding, windows, everything installed in the factory. And that, again, just reduces the amount of trades on site and reduces the overall construction schedule and cost of the project. So we're seeing a huge benefit to this. And it's not just a faster product, it's a high performance wall envelope. So we're seeing the shift from the old way of insulating a building. You can see on the right there with some stud walls, and you're shoving insulation in between it manually, to the one on the right. And that's a section of our clips prototype that we did in our factory. And you can see on the far left, you've got the drywall, and then you've got some strapping there that you can run electrical in between. You have the mass timber section, so that's a 3-ply mass timber, and we actually have a lot of outboard insulation. So the insulation is actually on the outside of the building now as opposed to the inside, which makes for a better, more high-performance wall with less thermal bridging because you have continuous insulation. This is an R40, so we're almost at passive house standards there, but we can do anything from code minimum all the way to passive house with this type of assembly. Just to add to the process of mass timber and offsite manufacturing, it does require that decisions are made earlier and more often, and we have to live by those decisions. So the old ways of getting to site and deciding what to do once you're on site and where to run that pipe and where to do that, those don't really work well with mass timber and an IPD collaborative approach. So this is the McLeany curve, and it gives kind of a good overview of that approach that we're trying to achieve with the mass timber. So on the x-axis, you see the project timeline go from pre-design all the way to operation, and on the y-axis, you have your level of effort. So the red line is your ability to impact costs, and you have a high ability to impact costs at the beginning of a project, and that diminishes as you move towards operation. The inverse of that is the green line. So we have the cost of a design change. If I'm sitting at my computer and I'm using a Revit model, I can move a wall or move a foundation, a column quite easily. It doesn't cost anything. I can do that in 2 minutes. If we're trying to do that on site, it's going to cost tens and thousands, hundreds of thousands of dollars to make those decisions. So your cost of a design change skyrockets as you move forward. The traditional way to do buildings is to design in silos. Mechanical does their thing, electrical does their thing, architects. There's some collaboration, but not as much as there needs to be. And everybody gets together during the construction documents phase and figures out all this clash detection and then starts making changes. And it's a bit of a it's a bit of a process. So what we're trying to do is we're trying to shift that to more of a collaborative approach where we make decisions along the number 4 curve. Early on in schematic design, we figure out the best optimized structural solution. We work with the MEP trades, we work with the architect, and bring everybody together early so that when we provide that building and we have all made these decisions, we know exactly what it's going to cost because we know right down to the last screw how this building goes together and every ounce of material that's in it. So we can have a very accurate cost with less changes on site, less RFIs, less question marks for the investor and the developer and the end user. So, that translates into schedule savings. So this is a pretty good overview of the different segments where you see cost savings and schedule savings with mass timber. So if we start at the top, the foundations, as I said, the material is lighter, so you have less soil remediation and you have less foundations. So you're saving time there already. The mass timber structure, depending on the level of prefabrication that you go into, you are saving time. The building envelope, if we prefabricate the building envelope, that goes up faster, saving time. The MEP, the penetrations are already cut out. All the guys have to do is get to site and put the pipes in. There's no cutting, there's no construction. It's just fitting it out the building, save time there. And interior finishes, we are using wood as the interior finish as much as we possibly can. We're saving time there. So the overall schedule gets reduced, and the overall congested sites, that's perfect for infill sites downtown where there's not a lot of room for laydown area. We're just bringing this stuff to site just in time delivery from our factory, which is 2 hours away. And it really just makes everything so much more clean. You can have 4 guys in a crane put up a whole building and then have the MEP and everybody else come and fit it out right afterwards. It's just a cleaner process, and it's really making a difference. So just to briefly go over some of the keys to success that we see on a mass timber project is you want to know which box you're trying to check. Is it cost, aesthetics, sustainability, rapid construction, or is it all of the above? But just kind of know why you're in this, why you're designing in mass timber. And, the second one is to design in mass timber from the beginning. A lot of our projects come to us, they're designed in concrete or steel, and it's tough to switch it back over to mass timber. And it's not a linear design process because we're doing rework. So you want to start off from the onset. I'm not saying we haven't successfully switched over a lot of projects, we have, but it makes it a lot better and more cost effective and time effective if we can start designing in mass timber from the onset. So get in early, get in at the schematic design phase. That's one of the keys. Understanding your supply chain is engaging with somebody like us, the manufacturer, to understand what we're designing to, what we can do and how we can do it. So that, again, eliminates rework and reiterating design work. Leveraging your manufacturer's capabilities. I went over some of our prefabricated products here. You want to know what vendor you're working with and what they can do for you. And you want to know how to maximize that level of prefabrication that we can do offsite and just optimize the whole workflow of the project. So just involving your supply chain, involving your manufacturers early is just a key to success. Optimizing the structural grid. So concrete and steel and mass timber, they all have different structural properties. So in order for us to keep a mass timber project economical and competitive with these other approaches, we need to optimize the structural base, so the column spacing. And there's a few different structural approaches we can do. There's post and beam, there's post and plate, there's CLT demising walls, but we need to engage with the architect and the EOR, the engineer of record, early in order to make those decisions. If it's left exposed to fire, that makes a difference because the wood gets thicker if it's exposed and you're achieving a fire rating. So those are just something to take into consideration, and it's a cost driver on the project. So getting that structural grid optimized early. I think I spoke about taking advantage of prefabrication. That's just, what your manufacturer offers, what you can do offsite. Maximizing the exposed timber. Everybody wants to see the wood, but you want to have a good code consultant on board to know what you're allowed to do, what you're allowed to expose. Different jurisdictions have different areas and different codes that they're following. And so even some building departments just interpret the code a little bit different. So you want to engage early and often with the authority having jurisdiction. You want to bring them into the design process and show them what you're doing. You don't want to hit them with a building permit set and say, hey, by the way, I'm building this building in mass timber and you've never seen it before. Please review. So you really want to engage them early, and it's a really, really good key to success is just to involve them in the process, and they feel involved, and they understand how mass timber works and what the advantages are, and they're going to be a proponent for you instead of a barrier. So that's a huge key to success. And then just working with people that are experienced. You want to have at least a couple people on the project team that have done this before. Because, it is still, we're on the leading edge of this industry and it's exploding, and there's more and more people that we can go to talk to. But just having, a mass timber vendor and maybe an engineer or an architect or just somebody on the team that's done it before to make the process a little bit more smooth, that would be some advice from us. And the last one is, you're creating market distinction. We're still on the leading edge of this. So if you can get in on the ground floor here and be one of the go-tos that say, hey, those guys have done this before, we should work with them. It can really make your firm or your consulting firm or stand out in the industry. So that's kind of a little summary of the keys to a successful mass timber project. And with that, I think we're right on time here, so I'll wrap it up.
It's 11:30. You are very good, Lee. Okay, fantastic. And I think Patrick has answered almost all the questions. Patrick, is there any question from the chat box that you haven't yet answered and you would like to bring publicly?
Well, I think one of the questions that came up was pricing. So I thought it would be better for us to address pricing issues, live, because obviously it's a common question. So, Lee, I don't know if you want to take a stab at price comparisons between mass timber and concrete or steel alternatives.
Sure. Yeah, so again, it comes down to designing the building with mass timber in mind from the beginning. There's certain building typologies that we're just not going to be comparable with because of how it was designed. But if something is designed in mass timber, I mean, we're very competitive with concrete or steel for certain building typologies. So anywhere from, I would say, a four-story building, a 25,000 square foot, four-story building, all the way up until an 18-story office or multi-unit residential building, we can be quite competitive with a supply and install number for concrete or steel. Single-family houses and lower story homes, like a townhouse or two or three stories, we're right on the verge of being competitive with light wood frame construction. But it's just a little bit more difficult. We start to see the value in the industrialized process of offsite manufacturing when you have a little bit more square footage that you're dealing with. And if the structural grid works for mass timber, then yes, we're quite competitive.
Maybe I'll just comment on that as well. So recently, we put a consortium together to bid on a mass timber YWCA project in Kitchener-Waterloo. As an industry, we said, recognizing that there's a huge affordable housing crisis, we said if we can build buildings cheaper, faster, and create these wonderful, healthy environments for people, maybe we have at least part of a solution to the affordable housing crisis. So we put a group of people together to bid on their YWCA project, and it was a design build process. And quite honestly, when we assembled the group, we weren't sure whether we were going to be competitive in affordable housing. And we were quite pleased to find out that we had underpriced about 5 or 6 other major competitors in the affordable housing space with an entirely mass timber building. So this building is designed with CLT slabs for floors, demising walls between units, roof structure, CLT elevator and stairwells with our prefabricated envelope panels on the outside of the building. And so we realized then that if we were able to offer a mass timber solution that was competitive even in the affordable housing space, that there are so many different kinds of applications where we could also be quite competitive. So yeah, we've proven, even in affordable housing, that a mass timber solution can be quite competitive. I think there was another question here about clips. How far does Element 5 take our clips? To the outermost girts only, exterior skin, etc. So I'll touch upon that. So we've developed our clip system. So these cross-laminated insulated panels prefabricated in our factory. It's kind of an evolving process. We've done 4 projects so far, but each of those projects, we've only taken it to the point of the pre-installation of the CLT, the vapor permeable layer, the insulation, and the strapping. It made sense for a couple of projects we've done so far to site apply the cladding and the windows. But as our product is maturing, we're offering a unitized system. We have to go through a little bit more testing in order to be certified to be able to do that. But in the not too distant future, we'll be able to offer a completely unitized system that includes the cladding and the windows.
And I believe that was the only question, the last question to answer. And thank you for having your contact info on the screen. If anyone, any of you has any other questions. We try to keep our webinars around 30 minutes. So we thank you for that. that was fantastic. I've received texts and emails thanking me for having you. So that's a good sign for me. Have a wonderful rest of the day, everyone. And Patrick and Lee, thank you very much for being here with us today. Have a great
Thank you
day,
very much,
everyone.
Nama.
Thank you, Nama.